All right. So before we kind of get going here, a couple of things I wanted to mention. So I since last class I've updated quiz number one. So there were some problems that had some decimal issues in terms of the margin of error that it was accepting. So I've made those adjustments. I think there was a couple other questions, and I outlined this in an announcement that was on Canvas, um, where the correct answers defaulted to the first one. So I've kind of updated those as well. One thing I do want to mention, there was one problem specifically, I think it was 17, and this will kind of be important for quiz two, but then also for the first exam, midterm exam, which is this Thursday. I'll mention more about that later on in the class. But anytime you have a drop-down question, it only displays the first four answers. So if you have more options, you're going to need to scroll down. So I would always make sure you're trying to scroll down on those fill in the blanks to make sure you can observe all options. That caused an issue on one of the questions. So kind of for that first midterm and exam number or quiz two, make sure you're paying attention to that. I put up another version of that quiz, and I'll unlock this quiz so you don't have to use the lockdown browser anymore after class today. So you can observe what your old quiz looked like, because it generates different random numbers every time you take the quiz. So that'll be available after class today. The study version, though, so this is kind of what you will see here in a second. So I'm going to go to preview. You guys don't have this option. When you click on it, you should kind of come to this page. You'll start the quiz. Just hit submit. And what it will do is show you what all of the correct answers should be. So this is going to be with all of those questions corrected. I even added in some clarifying points to it. This will be what you should be using to kind of study for that first exam. This will be a better version of that quiz to make sure that you're using that. Okay. Also, just in terms of due dates, I want to mention some things. So, excuse me, that quiz from Friday, that's due before we start class tomorrow. We'll have a daily quiz today. That's due before we start class on Thursday. We'll also have a daily quiz tomorrow, and that'll be due before that exam starts. I would suggest getting them done well in advance so you can start to use those daily quiz questions to study as well. We also have that kind of first Canvas discussion. That's due by the end of the day on the end of the day on Wednesday. And then this quiz number two, which will be available or open up after class today. That's going to be due at the end of the day. So usually these are due prior to starting class, but here, since we have that exam, I have it set to be due at the end of the day Wednesday as well. Once again, I would kind of start to try to work on that, study for that, and get that exam or that quiz done well before the exam. I put up quiz two practice problems. These will be really good study materials before you take that second quiz. Other than that, I think that's all of the housekeeping stuff here for today. Any other questions before we jump into material? So we'll kind of, hopefully, I think we'll have enough time to finish up these module 4 slides. And we'll be using that Excel file. I'll add some things in and post that up after class that has what we did on Friday as well as today, in addition to what it originally had. Okay. So any questions on that before we get going here? Okay. Make sure it didn't pick up this video. So it didn't. All right. So we left off thinking about growth rates and how to calculate new GDP or real GDP based off of an old GDP. Right. So we said the equation we were going to use was 1 plus the growth rate to whatever power, right, to the number of years. We're going to take it to the power of the number of years out. We want to predict what your new GDP is going to be. Okay. So to make this calculation is something that we'll use kind of moving forward today. I'm going to use that Excel file. I'm going to go to this importance of growth rates. I'm going to zoom in a little bit so we can see this better. But let's assume that I have an old GDP of 100. Okay. I then have a growth rate of 7%. Okay. And then the number of years out I'm trying to make this prediction for, let's set this to 10. Okay. So this is the kind of setup that I have. I want to predict what is new GDP after these 10 years. Okay. So the equation that we had for this was the old GDP times 1 plus the growth rate to the power of whatever number of years we're trying to make the prediction for. So I would say, okay, and I could do this calculation by hand. Here I'm just using Excel. I would take the old GDP, multiply that by 1 plus the growth rate. I will then take that to the power of however many years out I'm trying to make this prediction for. Now, if I hit enter here, holy cow, the GDP e to the 11 means move that decimal 11 places to the right. There's no way my GDP grows by that much. It's because when we're using that equation, I kind of mentioned this on Friday, we need to make sure that we're using the decimal form of that growth rate. Okay. So if I've got a growth rate of 7%, I would divide that by 100 to get it in decimal form. I need to be using the decimal form of the growth rate when I'm using this equation. There, I get something that's a little bit more reasonable. After 10 years at a constant growth rate of 7%, my new GDP almost doubles. Okay. So a little bit of review, which is a different example of what we talked about last class. I'm then going to go into a general rule of thumb we can use to determine when will a real GDP double. So the general rule of thumb is we would take 70 and divide it by the growth rate. However, here, when we're using that general rule of thumb, we divide by the growth rate as a percentage. So, for example, we have these questions. So I take the growth rate. At 1%, the number of years it would take to double is 70 over 1, or 70 years. At 2%, number of years to double, 70 over 2 would be 35, so on and so forth. Notice, as the growth rate goes up, the number of years it takes to double goes down, right? Our GDP is growing faster, and so it won't take as long to get that same doubling, right? So I could answer some of the following questions. How long would it take for my economy to double if the growth rate is 2.5%? And then also, assuming, right, that the GDP doubles in 22 years, what would the growth rate have to be? So I can kind of take these, we'll do the work in Excel. So shouldn't be too bad. If I have a constant growth rate of 2.5%, my general rule of thumb tells me that it should double in 70 divided by that growth rate as a percentage. So 28 years. Okay. Now I could also look here just to kind of support what we were doing before. If I had a growth rate of 7%, it should be 70 divided by 7 should tell me the number of years it takes to double. Sure enough, I get that same 10, right? So we could see here, doing the actual calculation, our GDP went from 100 to about 200 in 10 years. The general rule of thumb tells us that as well. What if instead we had this idea that it was going to double, right? But I didn't know what the growth rate was. I want to determine what what growth rate would cause my GDP to double. Let's make sure I have this number right. Oh, sorry, in 22 years. Okay. So here I had 22, or sorry, here I had number of years to double was 22, right? And I need to find what the growth rate is, and I can use kind of that just GDP of 100 starting out, which is kind of a way to do this. So here we have to do a little bit different today because this dot cam isn't working. So where is my option to do? Oh, should have. There it is. So we'll do a new whiteboard here. Okay. There we go. So if kind of the number of years to double, I'm not gonna be able to use this because I can't hardly write with it. So the number of years to double is going to be, oh my gosh, hold on. How do I want to do this? This isn't working very well. I thought this whiteboard would be easier to use. So I've got the number of years to double should be 70 divided by whatever my growth rate is. If I know the number of years to double is 22, it's just a little bit of math, right? So if I rearrange this, right, the growth rate I would need in order for it to double would be 70 divided by 22. Okay. So if I go back to Excel, and I say, okay, the number of years to double I know is 22, then the growth rate I would need is 70 divided by that number of years. So 3.18 would be the growth rate I need as a percent. So this is my growth rate as a percent. If instead I was asked for the growth rate in decimal form, well, we can always go from a percentage to decimal form by simply dividing by 100. Okay, so that's the growth rate there that I would need. Okay, so we can answer questions like this. As long as I know two of these components, or one of these components, I can always solve for the one I don't know. Okay, so with that in mind, we're going to start the daily quiz for today. So we'll come down here and kind of work along with me. So for this first question, and here we don't have to see the values just to kind of make sure that we can do this. So for this first one, all right, I'll have Excel to be my calculator here. Oh, if I can get this so that it's a little bit smaller. Right. So I know what my growth rate is as a percentage. I know that my real GDP is 215, and I want to determine what the real GDP is 1 year from now. Well, anytime we want to find our new GDP, it's our old GDP, which is 215, times 1 plus my growth rate. Now here, when we're using this equation, we said we always need to use the growth rate in decimal form. So instead of 4.8%, we'd be using 0.048. And then here, it's an easier problem than we would usually have, because if I only want to make the projection out for the following year, the number of years I'm looking at would just be 1. So you don't even really need to take this to a power. Anything to the power of 1 is itself. Right? So I can see here, at 4.8% growth, in 1 year, my GDP would be 225.32. Okay. Now, the second one, once again, shouldn't be too tough. We kind of actually already worked through this. If I have a current growth rate of 7%, then using that rule of thumb, I would just take 70 divided by that growth rate. Now here, let's not use the decimal form, right? If I did, looks like it takes 1,000 years to double, but that's because when we're calculating it using that rule of thumb, we use that growth rate as a percent, right? Or 7%. So here, similar to our other example, it would take that 10 years to double. Okay. Any questions on that before we keep moving here? Okay. All right. So hopefully, plenty of time to kind of submit this. If you're watching it after the fact, don't open these daily quizzes until I go through them. They should be relatively easy points. So the next thing that we're going to talk about is we have this growth, right? So what's going to cause our GDP to grow? So really 4 factors, and we'll kind of show that we simplify some of this for the sake of this class. But I've got productivity, other resources. For us, we're just going to focus on physical capital. This could be land, this could be raw materials, but for us, we're just going to think about physical capital. We'll then think about another factor of production, which is labor. Sometimes, we're going to incorporate another component, which is human capital or education. So when we first start out, I'll kind of simplify this. We won't look at human capital. We'll then kind of make it a little more complicated. What happens if we add human capital into the equation? So this is this acronym POLE. This stands for kind of these 4 different factors. Right? So if I'm thinking about labor and capital, labor specifically, right? We can think of this as the number of workers. Right? Technically, this could be like the number of hours of potential work our labor force has. But for us, we'll kind of keep it simple in terms of how we think about it. Available labor is just the number of workers that we have in the current time period. Now, how does labor change? Well, labor in my next time period would be whatever the current labor force started at, plus my inflows, minus my outflows. Okay, so what are my inflows of labor? Well, an easier way to think about this, I'm thinking about the number of workers. Inflows would be if I have increases in employment. Outflows, and here I wanted to mention, I should have this subscript I was copying and pasting, right? Should be all kind of in the same time period. So my labor outflows will not be employment, that would be unemployment. Or potentially we could think about this as people moving to the country, people leaving, right? So here's going to be our labor force. It would be the prior year's labor force plus the inflows and minus the outflows. Okay. So given the same amount of labor, worker productivity is going to matter. So even if I have the same number of workers, how skilled they are, right, could increase output by more. So how do we increase productivity of our labor force? We invest into education, right, or human capital. Now, I say education here. It doesn't have to be a college degree. This could be skills. This could be like a welding certificate. This could be anything that increases the skill level of our current labor force. All right, so human capital is any investment we make, either education or anything we invest in to improve the skill level of our workers. So how can we encourage this? Well, government policies, right? We might offer subsidies, Pell Grants to students so that they're more likely to attend college or increase their human capital, which we then will eventually get to is going to increase our economic growth, makes our current workforce more productive. They can generate higher levels of output. Okay. So just kind of setting us up here. Now, to kind of support this, if we look at the average years of schooling, and we plotted this for every single country, and then the GDP we see per capita in those countries, we tried to draw a line that kind of best fit this data. Looks like, sure enough, as education increases, so does GDP per capita. Okay. So kind of a nice data source that kind of supports this idea. Now, we're also going to focus on another resource, which is capital. So we could make this a broader category: physical capital, land, natural resources, or raw material. We're just going to focus on physical capital, which will be things like machinery, the tools we give our workers to generate output. This could even be something like a building, right, a production facility. So I'm going to denote physical capital as K. It's kind of weird that capital starts with C, but this is just the notation that we use in economics. What will physical capital changes be? Well, just like we have changes in our labor, we can also see changes in capital. So capital the following year will be whatever the capital was before, plus the investments that we made into those, into machinery, into those buildings, minus depreciation. So depreciation is going to be capital that becomes useless, right? So essentially, you could think about this as maybe I have some older software programs that become obsolete, right? And so my workers can't use those old software programs anymore. They have to use newer ones, so the old ones become obsolete. If I'm paying for them, they're no longer usable. That would be depreciation. Or my building becomes so old that it's in disrepair, I no longer can use it for my production facility. So investments would increase capital, depreciation would decrease capital. Okay, so this is another way of thinking about this is like aging technologies, or I like to use buildings because I think you can kind of picture that a little bit better. So when we're thinking about economic productivity, we know labor and capital matters. So we also have a third component, which is going to be, even if I have the same amount of capital, same machinery, I have the same amount of computers, but I also have the same number of workers, same labor, right? There's going to be things I can give that capital and labor that make it more effective. For example, I could give it better software programs. I could give it I could give it new technologies, right, that it could use. And so anything that's going to make that same level of capital and labor more productive, we'll call total factor productivity, right? So what would cause this? Primarily, we think about this in the way that I'll usually refer to it as technology improvements. That's the easiest way to think about total factor productivity increasing. Now, we might also have that taking B251, this might help solidify this idea. If we have competition, that means that, excuse me, companies, right, are going to put more time and effort into trying to make sure people want to buy products from them. If they're the only company, it's a monopoly, they don't have to work very hard. So increases in competition, right, make it such that our companies, also our employees, want to work even harder than they were before because they know if they don't, they might lose their job or people are going to buy from other companies. Right? So as we move towards a perfectly competitive market or we see increases in competition, that generally increases our total factor productivity. The same amount of capital and labor produces higher output than before. So a counterexample of this is going to be like electric companies. They're often regional or local monopolies. They don't have a very strong incentive to update their capital. That's why if you look at, the poles that support electric lines look like they've been there for 40 years sometimes, right? There's not a huge incentive to try to increase their capital. So that would be like the reverse, right? Less competition would lower total factor productivity. Okay. So we're going to have a function, right, that gives us the per worker output of a country. So we're going to define some things first, which is physical capital. We said that's denoted by K. Labor we'll denote with an L. Human capital, H, and we're going to avoid that for a second. We'll introduce that later on. And we would have natural resources. I'm going to simplify things for this class. We're going to just treat these like they are physical capital just to make the math a little bit easier. And then we're going to have this overall level of technology or total factor productivity. We're going to call that A. So my real GDP will be some function of capital, labor, capital, labor, human capital, and natural resources. We're not going to use natural resources. We're only going to use human capital after we build the base model today. So there's some function of capital and labor that would produce a certain amount of output. And then as we have improvements in technology, it's going to make that output, resulting output even higher. Okay. So these are our components, right? And generally, the production function we're going to use, and this is the one that we'll use for this class, is that real GDP is total factor productivity times K to a certain power times L times H to another power. And once again, if we had natural resources, we would include that as well. We're not going to add that into our model, make it a little bit easier. So with this idea in mind, right, what if I had the following? All right, so let's say I had total factor productivity of 20. So that would be my A. I have 400 units of physical capital, 300 units of labor. We're going to simplify for right now and assume that human capital is normalized to 1. So we're not going to include human capital into our production function. We're going to avoid that for right now. So if the following function gives me my output, right, K to the 0.3 and L to the 0.5. We also then multiply that by whatever the total factor productivity is. It's really just a matter of plugging in our values, right? So here, if I use that Excel file, I'm going to go over here to that per worker production function. I'm going to zoom in for us so we can see this a little bit easier. If these are my values that we were given, how would I calculate my real GDP? So I would take my total factor productivity. I would multiply that by whatever capital is, K, and I believe in the slides we had that to the 0.3 power. We would then multiply that by the amount of labor units I have to, I think the function I gave you was 0.5 in the slides, so to the 0.5 power. Now, these exponents can change. I would have to give you what that functional form is in order for you to make this calculation. Once again, you could enter this in your calculator. If you're concerned about order of operations, which might become a little more important when we add human capital in, I would just get used to just putting parentheses around things. Okay. So if I hit enter here, my total output I get from that level of capital and labor for this level of total factor productivity is going to be 2090. Right? Now I could change these values. If I increase A, I get even more output than before. If I increase capital, I get more output than I was before, etc. So that's going to be how we make those calculations. It's just a matter of plugging in our current level of total factor productivity or technology and our amount of capital and labor that we currently have. So when we're thinking about this per worker production function, right? If I assume I started out with this total factor productivity of 20, and I had that current amount of capital and labor, I could use this function and we can compute it. So something else that we want to be concerned with is that as I make more and more investment in the capital, so remember that capital equation, how did we make the determination of what our new capital would be? Well, we added investment and we subtracted out depreciation. So for this example, we'll just assume that there is no depreciation. We're just making investments into physical capital here. Well, the first $100 I invest, I'm giving my workers, going from giving them no machines to some. Well, what are the machinery that I'm going to first, purchase to give to my workers, whatever is the most effective or whatever they need the most first. So that first $100 is going to increase, first $100 invested in the capital is going to increase my output by quite a bit. So here we've got it goes from about 0 to 500. However, right, so that marginal output, the change in output was 500 over 100 or 5. Now, when I invest the next $100, so I'm going from 100 to 200, I'm buying more machinery or production facilities, but I didn't buy them first because they weren't the most effective, right? So I buy the most effective thing first, the next most effective second, et cetera, et cetera. So as I invest more into capital, I'm investing in things that aren't as efficient as before. My marginal output should go down. Sure enough, if I look here, that second $100, so 100 to 200, it looks like I'm going from 500 to 900, or only increase my output by 400. So that marginal output is decreasing. Anytime I invest in the capital, yes, it's increasing my output, but it's doing so at a decreasing rate. Or when you think about derivatives, the slope of this line is decreasing as I increase K or increase physical capital investments. So we would kind of call this the law of diminishing returns. As I invest more into capital, the change I'm getting in output is going down. Any questions on that before we keep moving here? Okay. So I already said this, but you can kind of see here, right? As we invest that same $100 in the capital, the change was less and less. Okay? And then that would apply to the next 100, right? So what if instead, right, we have this kind of function of capital and the output that we're getting from those different levels of investment, but we have improvements or changes in technology, right? So if this was our real GDP function, our output was some function of K. As we increased K, it increased the value of this function. It increased at a decreasing rate, but it still increased it. Well, what if A increases? Well, that would mean that at the same level of capital, that would produce the same value from this function. However, if it gets multiplied by a higher value at every level of capital investment, our new real GDP multiplied by a larger value, will increase. So there's two ways of thinking about why this is the case. So let's say I wanted the same level of output. Before, I had to make a $300 investment into capital. After this technology improvement, I don't need as much as before, right? Because the same amount of capital is now more effective or more productive. So to get that same approximately 1,200 units of output, I don't need as much capital as before. I need less, right? So that's one way of thinking about why technology improvements are actually going to increase this production function. Another way of thinking about this is the same level of capital investment before it was producing about 1,200 units, but that same level of capital is now getting multiplied by a larger value. So after that technology increase or total factor productivity increase, the same amount of capital will lead to higher levels of output. So it's going to increase this production function when we see increases in total factor productivity. And the same, when we're working through these examples, the same thing would apply to labor, right? If I think about the amount of money I'm investing into labor, it's also going to be kind of increase that production function line if I have increases in total factor productivity. The same amount of workers will become more effective with higher levels of technology. So we would see at the same amount of labor, we get higher output, similar kind of idea with capital. Now, what's also going to happen, and once again, I don't have this dot cam working for who knows what reason why this room decided not to work today. Let's say we have that real GDP function. If I see that capital is increasing, we said we know that it's increasing output, but at a decreasing rate. Right? That was why the slope of this line gets flatter and flatter. However, if I see a total factor productivity increase or technology increase, at every point, the same investment in the capital we said would increase our production function. Now notice, at the same amount of capital investment, before that technology change, this was like our marginal rate or our marginal output from that investment in the capital. When we have this higher level of total factor productivity, the same amount of capital should add more to output, or the marginal output should be higher, or the slope is going to be a little bit steeper. So a little bit hard to kind of see that with these lines, but if you're comparing the gap here, smaller than the gap out here, the slope of my production function line as total factor productivity increases will also increase. It makes the same amount of capital investment, the same amount of capital, add more to output, or the marginal output is higher, in which case that means the slope is going to be steeper. Okay. Any questions on this idea before we keep moving here? Okay. So, thinking about this per worker production function and how total factor productivity or technology improvements affect it, let's go a little bit further. Right? So even if total factor productivity or technology stays the same, how could I cause my economy to grow? I could increase my factors of production, either capital or labor. Now we can increase our total factor productivity, but let's assume that we can't. Well, then we can still make investments into capital and labor, even if technology doesn't improve. So I'll go through kind of an Excel example. We'll use that same production function we were using before that has those same exponents. We'll then think about how would my real GDP be impacted by 10% increases in each one of these. Okay. So I've got kind of the math written out, how you could enter this into a calculator. We're going to do this in Excel. Right? So here, if these are the values I started out with, 2,400 and 300, we'll think about what is my new GDP, right? If I had 10% growth in each one of these factors, okay? And then what was the resulting change in my GDP, okay? So all I did in these cells is I thought about, okay, I'm going to have this function, total factor productivity times capital to the 0.3 times labor to the 0.5. If I saw a 10% increase in total factor productivity, that would be what? 20 times 1.1, or give me that value of 22. So if I wanted to calculate new GDP, it'd be the same levels of capital and labor, but now instead of 20, I'm going to be using that total factor productivity of 22, that 10% increase in total factor productivity. So if you don't want to use this like equation, you could have just put in 22 here. You should get the same value, right? So the one that you'll kind of see posted, I'm using the cell references, but if you wanted to break this down to intermediate components, you could. I'll then think about, okay, what was the change in my GDP? Well, here was my new GDP. Here was my old GDP, right? So I can figure out this change in total factor productivity, a 10% increase, caused my production to go up by about 209. Now, let's think about that same 10% increase, but if it was in capital. Well, a 10% increase in capital would be 400 times 1.1. My new amount of capital is 440. So instead of that old value, when capital increases by 10%, instead of using 400, I should be using 440 here. So if I do that, I see, okay, my new GDP is higher than before, right? But what is the difference? So I take my new GDP minus the old GDP, it only increased by 60. So that same 10% increase in capital didn't have near as large of an effect as that 10% increase in total factor productivity. This kind of highlights that, total factor productivity is really important. Okay. In fact, you could do something like, let's think about what if instead this was 0.05, so it didn't grow, only grew by 5%. It still increases real GDP by more than a 10% increase in capital. So total factor productivity, very important. We could then do the same thing for labor, right? A 10% increase would be 300 times 1.1. If I use that 330 in my equation, or I can kind of, just multiply the old amount by 1.1 instead of breaking it down to intermediate steps. Well, here, from labor, that change was my new GDP minus the old. There I see that increasing labor by 10% actually increased my real GDP by more than that 10% increase in capital, but still less than that 10% increase in total factor productivity. So what if we had a slightly different example? Okay, so it's not always going to be that labor increase, the same percentage increase in labor is going to increase real GDP by more than that same percentage increase in capital. So I'll kind of highlight what actually matters. So I'm going to do Control C here. Oops, maybe. So copy and paste this. Okay. So same exact values. But what we're now going to do is change this functional form. And instead of to the 0.3, we're going to take capital to these, let's say 0.6, and we're going to take labor to the 0.4. Okay. So I'll highlight why this matters here in a second. But when I hit enter here, everything, I could kind of hit that there, and then we go through here. I'm going to change all of these to 0.6 and 0.4. If I put these in a different cell, then it would actually make this a little bit easier. So I'll change it manually though. Oops. And then here, we're changing the functional form. So our exponents are different than they were in the prior example. So what we now see is those same 10% increase. Oh, what did I want here? Oh yeah, I changed these. Okay. So what we're now going to see is what increases real GDP the most. Still going to be growth in total factor productivity, right? 700 is way higher than these two. But that same 10% change in capital and labor, capital is now changing my real GDP by more than that 10% increase in labor. Why is that the case? Well, when I'm looking at my production function, if the exponent on capital is ever greater than the exponent on labor, that means the same amount of capital should increase real GDP by more than labor, right? Taking anything to a higher power is going to produce a higher value. So down here, so up here, sorry, we had 0.3 was the exponent on capital, 0.5 was the exponent on labor. So anytime the exponent on capital is less than that exponent on labor, right? If that's the case, then the same percent increase in capital would change my real GDP by less than that same percent increase in labor. Okay. So here, let me see if I can wrap text here. I'll scroll over here. So I'll kind of have this in a saved version of Excel file. So you can kind of think about anytime the exponent on capital is less than the exponent on labor, then the same percent change in labor will produce a larger change in my real GDP. The exact opposite will hold. Notice in this second example, now the exponent on capital is larger than the exponent on labor. So if I have that the exponent on capital is larger than the exponent on labor, essentially capital, instead of typing this out, will increase real GDP by more, right? Or the same percentage change in capital would produce a larger increase in real GDP than the same percentage increase in labor if this holds. So we can look at those exponents and know which factor of production is going to become more efficient if we try to increase it. In which case, if the exponent on capital is higher and I'm choosing what to invest in, I would want to choose to invest more in the capital than my labor. I know that would be more effective at increasing my overall output. Okay. Any questions on that before we keep moving? Okay. All right. So we can work through some other examples here. So what would happen to my real GDP if total factor productivity is higher, but I also, and sorry, here's some of those values. We worked through two examples, and I also kind of pointed out that really total factor productivity is the thing that's going to cause growth to, the most growth in our real GDP. So let's instead assume we have this example, same production function as before, but I now have that total factor productivity is higher, but the investments made in the capital decrease. Okay. So when I'm thinking about, here, I'll try to use the whiteboard. I might just draw this out, but we'll see if I can get this whiteboard to, be a little bit better. So here I've got my function. So I'm thinking about GDP is equal to this total factor productivity. This mouse is really tough. Let me see. Oh, there we go. This might be better. There we go. So GDP is equal to that total factor productivity times K to, I think we had 0.3 here, and labor to 0.5. So if my total factor productivity increases, what that's going to do is it's going to increase A. But if at the same time I'm making lower investments into capital, well, we said capital was my old capital plus my investments minus my depreciation. So if I'm increasing my investments, that should also, sorry, I think it was, let me make sure. Yes, so I'm decreasing what I'm investing into capital, right? So if that's the case, I would see that capital goes down, in which case, what's going to happen to GDP? The answer would be, we don't know. Unless we know something about the relative size of those changes, because they're working in opposite directions, we don't know what's going to happen to GDP. Okay. So another way we can think about this is something that would give us a similar result is we said that my new capital is going to be my old capital. I'll hold this. Plus my investments in the capital, but minus depreciation. So instead of decreasing investments in the capital, what if we saw an increase in depreciation? So make that arrow look a little bit better. So if I have more depreciation, so this is like, my buildings are falling into disrepair at a higher rate, I have an increase in depreciation, what's going to happen to my overall level of capital? Well, if I'm subtracting a larger value, that would cause my capital to go down, which is the same impact as if we lowered our investment. So I could set the problem up this way. So if I had an increase in total factor productivity, but also an increase in depreciation, that causes capital to go down. I don't know what's going to happen to my real GDP. Okay. Any questions on this idea before we keep moving? Okay. So let's think about some other examples, right? What if instead we also factor in human capital? Okay. So if I'm now factoring in human capital, our production function is going to look very similar to before, but we're going to be multiplying our labor by that human capital investment. So before, one thing that you'll kind of be told to assume in certain problems, if we're like assuming away human capital, is that you would assume human capital is normalized to 1. And then any investment in human capital would cause it to increase from 1. So how effective our labor is will be whatever our number of workers are times whatever their skill level is. So if their skill level goes up, then really we want to kind of multiply our number of workers by whatever their skill level is, and then we take that to whatever the exponent was. Okay. So let's think about the following scenarios. What happens to real GDP? And let's assume that capital and labor are the same, but the investments are made into, what happens real GDP if they remain the same, but investments are made into human capital? Okay. So essentially, we can think about if you increase the skill level of your current workers or you make investments into human capital, that should increase the effect of whatever your old labor was. So it should make that increase even larger. Right? So we can look at some values here. We'll go to Excel and I'll kind of use some of that the old numbers to kind of prove this. Okay. So let's use the original example. So I'm going to just drag this down and we're going to use the original values here, but I'm going to use instead this new production function we have where we're incorporating human capital. Right? So let's say my human capital investment was 1.5 and 2. We'll think of two scenarios. So remember, how do we calculate what real GDP is? It's my total factor productivity times my level of capital. And here we had to the 0.3 power. And then multiply that by the amount of labor we have. But now we're also going to multiply that by our level of human capital. That then gets raised to the 0.5 power, same functional form we were using before. Now, once again, I don't think it's too much of a revelation that, okay, if I'm now multiplying labor by something that's greater than 1, it should increase my real GDP compared to the old value. Sure enough, it does. And then as I make higher and higher investments into human capital, right, I could use that same function, say, take total factor productivity times the amount of capital I have to the 0.3 power, and then multiply that by the amount of labor I have times the investment I made into human capital to that 0.5 power. Now, if I do this, okay, as I make higher investments into human capital, my real GDP goes up by even more than it was before. Okay. So this kind of shows the importance of human capital investment and how much it is going to increase our GDP. Any questions here before I get out of this Excel file for a second? Okay. So let's think about some other scenarios, right? Just kind of adding in some different ways to think about this. So let's say I've got that same production function, right? What happens if I've got, so we're kind of going away from human capital here in a second. I'll show you some other ways we can change this example here on slide 26 if we incorporated human capital. But let's say I've got the first scenario, if I've got depreciation and it's greater than the investments I'm making in the capital. So once again, I don't have the dot cam, so I'm just going to use Excel to kind of type this out. So remember, kind of my current capital was equal to my old capital, right? Plus investments in the capital minus depreciation. So if I see that I have an increase in depreciation, what's that going to do? Well, if I'm subtracting a larger value, that's going to cause a decrease in my current amount of capital. Okay. So what was real GDP? That was equal to my total factor productivity times, we'll use K to the 0.3 times, L to the 0.5, right? So if I have depreciation increasing, I know my capital level will be decreasing, which is then going to cause what? My real GDP to go down. Okay. So if I have depreciation increase, that's going to lower my overall level of capital as long as that depreciation is greater than the investments I make. And that's going to cause real GDP to decrease. What if instead I then have that my employment is increasing by more than my unemployment? Well, similar kind of idea, right? We said that my current labor is equal to whatever my old labor was, plus labor inflows minus labor outflows. Okay. So if instead, right, I've got that my labor inflows are greater than my outflows, right? Then I know this difference will be positive, and then I'm going to see, here, let me see, I can go to, I want to make this, right, there we go. Oh. Sorry, Control Z this, make this a different color, right? So if I have more employment than unemployment, that's going to cause this difference to increase, which would then cause my current labor to increase. Well, once again, if this is my real GDP equation, if current labor goes up, that's going to cause my real GDP to go up. So these two things have competing effects, right? Higher depreciation means that capital will go down and real GDP goes down. More employment than unemployment causes labor to go up or the number of workers to increase, which will increase my GDP. So to kind of throw all these together, what we just said was decreases in capital were a result of increases in depreciation, and then increases in labor inflows minus outflows cause labor to go up, which caused real GDP to go up. So if these two things happen simultaneously, what's going to happen to real GDP kind of goes back to that example that we were using before, which is, it depends. We would have to know something about the relative size. Okay. Like I said, I wanted to pivot here instead of doing this on the dot cam. So if there's any questions here, let me know. Okay. All right. Before we go to the next topic, I do want to do one more thing and really highlight this fact. So let's go back over here. And thinking about this example where we had human capital. Okay. So let's say I had, oh, let's see, how do I want to do this? Let's just kind of start out with these values. So before I was calculating my real GDP using that functional form, okay? Let's instead assume that I've got decreases in labor, but I'm increasing human capital. So before we do that, let's just say, okay, let's calculate our new real GDP, and let's do that for a human capital value of 2. Well, everything's going to be exactly the same. We take total factor productivity times capital, and we said, I think in this example, was to the 0.3, times labor to the 0.3. But now we're factoring in human capital. So this is now going to get multiplied by 2. We would then take that product to the 0.5 power. So hopefully, if we're paying attention to what we said before, increases in human capital should increase our real GDP, even if labor and capital, physical capital stay the same. Sure enough, our new GDP is higher. Now, what if instead, right, we saw a decrease in labor, we know that's going to cause the real GDP to go down. Right? However, if labor decreases, we could actually still see an increase in GDP. So for example, the US right now has a birth rate that's less than 2, which means over time, we're going to have fewer workers than we used to, right, eventually. So what if our labor decreases? So let's say I've got this kind of same values. If I change labor instead to 200, we know that's going to lower real GDP if we have the same level of human capital investment, normalized to 1. However, even though labor is decreasing, when we invest human capital and more in human capital and that increases H, it might not be that our GDP was lower than it was before. So in fact, if we hit enter here, okay, my new real GDP from lower labor would be lower than it was before. It's now less than 2,000. However, that reduction in labor was compensated for by investments in the human capital. So we still could see that relative to before, so 2,400 was greater than the initial starting amount of 2,090. Right? It won't increase it as much as if we had that higher amount of labor, but their decreases in labor are still going to potentially allow me to see an increase in real GDP, right? As long as we're making investments in the human capital. And the reason why, well, if I have fewer workers, but each worker I have is 10 times as productive as before, I could still see that my overall level of output increases. Okay. Any questions on that before we kind of pivot to the last topic for module 4? Okay. And I could start to like do any combination of these things. So, the most complicated would be, let's say I had this production function, right? And I told you that we have increases in depreciation, while at the same time we're investing more into human capital. Well, there, depreciation going up actually decreases capital. Human capital investment increases this here. We have competing effects. The answer could be it depends. Now, the answer won't always be it depends. If I gave you another example where I said total factor productivity increases and the amount of employment is greater than unemployment, well, if employment is greater than unemployment, L would go up. Well, if they're both increasing, I know that real GDP has to be increasing. So directional changes in any one of these components, right, kind of doing simultaneous changes, are all kind of fair game questions I could ask you. Okay. And then because I think we have enough time here, to the earlier point, let's say I had in this example the same 10% increase in physical capital that I did into human capital, right? So in this example, which of those would cause a larger change to my real GDP? Well, it's the same idea that we had before. Whichever one has the higher exponent, that's going to be the effect that is larger. So a 10% increase in physical capital would change my real GDP by less than that same 10% increase in human capital. Okay. And that's because that exponent is less. Okay. So, that I'm just kind of basically, it's the same thing as when we had a change in labor. It's just a change in human capital. So I want to mention that before we move on. Okay. So the final thing that we'll talk about in module 4 are the different economic stages of development. So we've got kind of 3 stages. We'll kind of look at some data that supports this idea, and then we'll talk about how it relates to economic inequality. So most economies, if we go far back enough in time, and there are still some currently, but at lower levels of real output, lower levels of GDP, which if we go back in time, every country had lower levels of real GDP, that initially, like, what's the first thing we need? We have to feed our citizens, right? And so initially when GDP is low, most of our resources are going to go towards producing agricultural products, or we'll be in the agricultural stage. As we see increases in GDP, we've got plenty of food. What do we start to focus on? Producing products that make our lives better, right? So we start to manufacture things like improvements in materials that are used for homes, automobiles, etc. So once we have a high enough GDP, we start focusing on these physical products, or we're in the manufacturing stage. Or we're manufacturing things like there's a lot of countries that, we don't produce a lot of iPhones in the US. Another country is producing those and we import them. So we're not really in the manufacturing stage, but other countries are. We've actually progressed to the services stage, right? So you see really advanced economies with higher levels of GDP, instead of focusing on the production of certain goods, they focus on what can those goods produce. So instead of producing iPhones and laptops, how can we use those to provide financial services? I think of a current one right now. We don't produce as many cars in the US, but what's a market that's popped up? Uber and Lyft, right? We're producing kind of services as opposed to manufacturing those goods, right? So as GDP per capita, and I should make a I tend to be lazy with my speech here because we've already talked about we should be using real GDP. As real GDP per capita goes up, we progress through these stages. So just some data to support this. This is some real data that came from 2024. We've got all these different countries. We have their GDP per capita, and we have the percent of their GDP that came from agricultural production. Right? So notice that as GDP levels are higher, countries tend to produce lower levels of agriculture, at least in terms of a percent of their overall GDP. So countries with lower GDP tends to be the goods they're producing as a higher level of agricultural products. They're in the agricultural stage. As countries have more GDP per capita, well, what starts to happen? Well, now the percent of GDP that is in the manufacturing, and it goes into manufacturing, as GDP goes up, they start to produce more and more manufactured goods, not agricultural products. Why, though, if I try to draw a line that best fit this, it wouldn't look just like a nice linear line. It actually has some like curvature to it. So we can think about why. Initially, as I see increases in GDP, I start to produce more manufacturing goods. But at a certain level, we said we move from the manufacturing stage. If I continue to see increases in GDP, I won't be producing, in the manufacturing stage, producing physical products. I start to move towards that third services stage, right? So initially, these agricultural economies are moving to the manufacturing stage, but then over time, they leave the manufacturing stage, and, as GDP grows, we start to see these really wealthy economies start to really increase the percent of their GDP that's in services, okay? So notice like countries like the US, the United Kingdom, they were down here, right? Because they had already progressed into that services stage, okay? Any questions on this? We've got 5 minutes to kind of cover the last thing I wanted to go through today, which is the relationship between GDP growth and income inequality. So once again, this is actually a part of today's class that would be much easier to do in the .cam. I will post up under our playlist my earlier sections video. So you can go to the end of that if you want to kind of maybe more visual, an additional visual description of this last topic. But I think given what we have in the slides, I can at least get this information out to you pretty well today, okay? So when we see GDP growth, initially, that's going to cause some increases in income inequality. As our GDP grows, it's going to be heavily saturated with a smaller number of individuals. And so, whoever is the most highly skilled or whatever businesses are providing the most profitable goods, they're going to see increases in income whereas everybody else won't. We see an increase in economic inequality. However, as we continue to progress, right, more and more individuals develop these high skills, there's more competition, right? And I have more social mobility. Well, now anyone who is willing to, try to improve their skill level is able to, and we see that economic inequality actually decreases. Now, this is also helped out by government welfare programs. They start to take more money. The tax rate, if you're really wealthy, is larger than the tax rate if you're not. We start to take some taxes from the wealthy, give it to lower income individuals. And we're actually reducing economic inequality when we have higher and higher levels of GDP growth. So this relationship between GDP growth and income inequality can be reflected by, or kind of depicted by, the Kuznets curve. So this is all the Kuznets curve is. It's like an upside down U. So initially, when GDP growth is low, that's going to cause economic inequality to increase. When GDP growth is high, well, there, as we start to increase GDP growth, now economic inequality starts to decrease. Right? Now, a further point we can make here is, initially, the same increase in GDP growth down here is going to cause a much larger change or a much larger increase in economic inequality than if we saw the same increase in GDP growth up here. That's not increasing economic quality by much. It's still increasing it, but not near as much as it was at the lower levels of GDP. So we would say here, when GDP growth is low, increases in GDP growth would cause economic inequality to increase, but at a decreasing rate. Right? The change in economic inequality is getting closer and closer to zero. Now, at a certain point, where exactly that is, it's hard to determine. I mean, at least for the context of this class, if we had real world data, we could probably estimate about where this is using like econometrics, or linear regressions. At a certain point, though, now as we start to see increases in GDP growth, well, initially, it's going to cause my economic inequality to start to decrease, right? This is the idea. There's more social mobility. The government starts to redistribute wealth from the wealthy to the less wealthy. And so at a certain point, our economy growing is actually going to start to decrease economic inequality. And then as it grows more and more, that same increase in GDP growth is going to start to cause economic inequality to go down by an even larger amount. Or at higher levels of GDP growth, we start to see economic inequality decrease, but at an increasing rate. That's the idea of our Kuznets curve. So some of the things I was pointing at with my mouse, that's where in that additional video, you scroll, go to the end of it, you can see me, I'll draw this out and kind of put some dashed lines here so we can kind of think about what those changes look like. But the overall story is the same as what we have here in this slide. Okay? Low levels of GDP, as we see higher growth, increases economic inequality at a decreasing rate. Higher levels of GDP growth, if we see even more increases in GDP growth, starts to decrease economic inequality by an increasing rate. So that should cover it for Module 4 material. One thing I kind of want to mention before I let you guys get going, I realize we're right at the end of class here, but we have everything we now need to kind of go through that second quiz. So I put up those practice problems. So a second quiz will cover Module 3 and Module 4. Tomorrow and Wednesday's class, we are going to just do review. So I'll work through some of those practice problems. If you have any practice problems you want to see me work through, feel free to email me. I'll kind of put up a list, or I'll collect a list of those, choose the ones that I saw the most frequent in my emails. Or I have some additional examples I'll kind of bring in that I think might be wink, wink, really helpful for that first exam, which is Thursday. Oh, sorry, I don't have to be in here as a rush. I said this in my other class. This is off topic. I'll come back to the exam. But my watch is always, for whatever reason, it's connected to my iPhone. It's always 4 minutes faster than what the actual time is. So I look at my phone and my watch, and I always think we're about to end and we still have a couple minutes. So just so I don't rush through this, what I wanted to mention about were those review sessions. I already kind of mentioned you can email me. I'll bring in some additional questions I think would be really good to be able to work through. Make sure I have a working doc cam tomorrow. So I actually will bring my own doc cam and not rely on the rooms actually. But that first midterm exam will be on Thursday, okay? So you're gonna have to use this lockdown browser. So hopefully after quiz 1, I didn't hear from too many of you, it was working well. Quiz number 2, make sure it's working and that you can get everything kind of running with that lockdown browser. I'm gonna use the same one for this first exam. I think I originally had that it would be available from 11:15 to 3:30. I'm gonna open up the window a little bit so that just to give you a little more flexibility, and I'll still be available via email just in case anything pops up as you're taking that first exam. You can start it anytime between 9:30 a.m. and 3:30 p.m. is when it closes. So you'll have an hour and 15 minutes, so regular class time, to sit down and take that exam. Once you start, you can't pause it, which means if you want the full time, you'd have to start it by 2 p.m., our usual class time. Or sorry, 2:15, right? Because I have the due date or due time set to be 3:30. Okay. So I'll post this in an announcement, just kind of widening that window a little bit to make it a little bit more flexible for people, given some of you have internships, things like that. But that is the only time that will be available. You have to have it submitted by the end of that time window in order to receive any credit. Okay. Excuse me. Other than that, I will kind of end the recording here, but if you have any other questions, feel free to hang around and ask me anything that you might, not want part of the recording. If I can find, where's my recording button here? There you go.